Okay, so here I am today, and this time we're going to do overloading functions. And overloading functions does sound like a bizarre terminology, doesn't it? Well, basically, let me go ahead and throw the functions out, and you'll immediately understand what overloading functions is going to look like. So here, we use the same compute area function, but what's different is the arguments. We add additional arguments, and sometimes even a different type of argument. Functions overloading allows functions of the same name to happily coexist in the same program, provided their arguments different in number, data type, or both. And to demonstrate, I'll go ahead and get my program going. Now, we already went over what defining a function looks like, so I'll go ahead and quickly just paste everything we're going to define here. So the first compute area, we have one float argument here, which we input as diameter. Whatever we input in this variable, we'd be divided by 2. It'll become radius and do this sort of math. And so on. So let's get started with our main function. So I'm going to go ahead and type out some variables here. Float num and an area. Those will be my two variables. And I'll go ahead and get the first chunk of statements out here. So we're going to get a strings output, enter a dimension in feet. It'll want an input of num. Then num will be entered in to this first argument right here when we put it in this format. And then, yeah, like notes here, we'll say it'll apply to the first function. It'll spit out the string, and it'll go on and do so. Next up, I'll go ahead and put this one in there. So in this format, it'll send it to the second function. The same num that we entered in initially will go to the second function, and the cout statement will start displaying such. And this is what the third little function argument is going to look like. And this is what it's going to spit out. Now, what's interesting is t is there for no other reason other than to satisfy the argument. If we made it num, it will perform this. But because we want a character, we're just going to throw a letter in there. Arbitrarily, we chose t. Now let's go ahead and run this program. It does look a little involved. I even have to scroll down a little. But bear with me. Let's go ahead and do this. Let's get to the right position. Okay, so enter a dimension in feet. Okay, what dimension? Let's just throw in 4. How's that? Okay, we could have better done a string, but that's besides the point. So let's disregard that. Let's say we just knew that we should enter 4. Now 4 will go into this thing right here, where 4 will be divided by 2, thus making 2 times 2, which is 4 times this, which is pi to some odd decimal places, which does seem to match up with this. I'm quite positive. Then 4 will be applied to this area right here, where it simply becomes 4 times 4, and that does become 16. That's good. And then here, t falls into this slot, and then 4 falls into here and here, where 4 divided by 2 equals 2, and then 2 times 4 equals 8. And just for fun, we can try out a different number. It does the same math. It's a little trickier to do the math with that 2.5, but just by looking at it and discerning, it should approximately effectively do the same thing. So yeah, I mean, I think I ran through this rather quickly, but if we just look at it, soak it in, basically that is overloading.